Good morning, everybody. It's a bit high. Good morning, everyone. My name is Yusuf Khalidi. In this morning's presentation, I'll be presenting a topic to you, which is how to bridge from on-premises to the cloud. The basic question is this. You may be faced with a question of move a service or an application set, which is sophisticated, which is a graph of components talking to each other, from some incarnation being on-premises and the like to the cloud. How do you go about that? What are the issues you need to think about? What's the starting point of moving sophisticated apps to the cloud? So in this presentation, think of it as a framework, as a way to think of where do I start, what questions do I ask, and what questions should I be able to answer to make this thing possible. A quick overview over the presentation. We'll discuss briefly the opportunities and the challenges in doing something like this, which is moving sophisticated apps to the cloud. The main thesis is the following. There's actually a spectrum of possibilities for deploying your application and components of your applications, all the way from on-premises on traditional IT, all the way to cloud, public cloud systems. And there are actually value points along the spectrum, and sometimes needs to put a component here versus there. As I mentioned, I'll present the framework, a way of thinking about this, questions to ask before you actually embark on the job. And we'll discuss some of the technologies available today and possible future ones that can be used to make this thing a possibility. Lastly, this is a future-oriented presentation. It actually builds on what you heard Bob speak half an hour ago and goes into some possibilities of how we can actually achieve the ability to actually move things from on-premises to the cloud. Okay? I promise you to leave enough time for Q&A at the end as well, but if you really feel like it, stop me, okay? So what is cloud computing? You've seen many definitions. The salient point here is that you have a way to have dynamic, scalable, virtualized resources that can be provided as a service, typically over a network connection, over the internet. The key points here is very dynamic, and it's very scale up and the like. In this definition, it doesn't actually say much where do you run the stuff. Actually, it doesn't even say if it has to be on the internet or not. The key point here is that it's an application model, really, a way to think about how an application should be structured to fit in a cloud-like model. So regardless of the location, regardless where you want to put the thing, the application should fit in a cloud application model. Scale out in nature, service-oriented, you can get it through the network. And it's model-driven. You don't have a human to go in there and change every configuration setting by hand and so forth. Key point here is that this is applicable to traditional systems, on-premises, traditional IT, all the way to public clouds. So we would like you to think of terms of how do I make my new programming, my new applications, my new components written in a way that fits the application model, such that you retain the flexibility at deployment time for whatever reasons, and I mentioned many reasons. You may want to deploy it on-premise, on a public cloud, or on a private cloud. Okay? So key point here is that the application model, as much as we invest in making it more cloud-like, it will benefit throughout a wide spectrum. What spectrum am I talking about? So let's talk a bit more about the spectrum here. Yep. Let me use an old technology. Think of traditional IT first. These are traditional data centers that perhaps your central IT department, or you may be working there, run. These are very well-known, robust, stable systems. They can be very heterogeneous, though, and that's where many computation today runs in the server systems. They suffer with one big problem, to be honest, which is they have very low utilization. I'm actually being kind of generous when I say 15% utilization. Usually very low utilization. The industry at large has been, over the last several years, taking these traditional systems and making them virtualized systems. And how do you do that? You put a hypervisor, a bunch of VMs. But by and large, the application is still the same. You're just taking the same stuff and compacting them, taking those disparate machines all over the place and put them into with a nice hypervisor and a VM and put them together. What do you gain? The best thing you gain, the most important thing you gain is much higher utilization. Utilization upward of 50% is possible. And that really translates into big reduction in cost. That's all nice, but there's more to it going forward, which is the cloud model, really. In private clouds, you retain the ability to have on-premises control of your computational resources, your applications, and your data. They can be under lock and key, yet have many of the advantages of the cloud. And that's due to the fact that the application running on a cloud-like system is very much a scale-up application that's service-driven. A key point here is that there's an investment to make the application fit the cloud model, but in return, you get the advantages of that of a cloud system. In a sense, there are a bunch of restrictions you end up having to live with. Very uniform systems, very scale-out systems, and so forth. And of course, at the end of the spectrum, you have public clouds. And public clouds have the beauty of being very, very large, capacity on demand, just like that. There are very much multi-tenant systems. So some cases, as I'm going to mention time and again, you cannot necessarily be in a public cloud because certain data, for example, cannot live in a public cloud. But it's a very important part of the spectrum. Our strategy, our basic thesis, guys, is that there are benefits of choice across the whole spectrum. And we will continue to support the whole spectrum. Moreover, there will always be some data, an application set that have to live in a certain part of the spectrum. For example, under lock and key inside a data center because of regulation, compliance, or national laws. At the same time, many of us want to be able to utilize the cloud at large. So there are benefits of choice where you land in that spectrum. And what I want to discuss more with you now is that if you have an application set, a service, a scenario that you want to go target to the cloud, where do you land it? Where do you put the component in which piece, and why would you do that? To put this in a picture, this is very similar to some other stuff you may have seen. You have the enterprise behind walls. You have traditional enterprise internal IT. They could be virtualized or not. You may have private clouds. Salient points of a private cloud is it is under lock and key. So you can actually have much higher guarantees on privacy and the like. But they are lower scale than what could be a public cloud. And you can have variations on that, like dedicated clouds, which are basically clouds that may belong to you, but they're hosted by somebody else. And you want to be able to federate them, talk to each other among these clouds. And I'll mention some technologies around that in a second. And the way you would use it is very much you author your application, and you decide which component has to be targeted to which deployment environment. The last demo you have seen in Bob's presentation, for example, was leading toward this kind of picture. But let me click down some more details here. What does it mean to target one environment over the other, and why would you do that? There are three basic opportunities that we can all achieve here by moving to a model like I'm describing here. One is the ability to build very rich applications that can be targeted to the cloud while still preserving much of the symmetry, the investment you have done with the enterprise. And you have seen us having more and more tooling and programming language support and so forth, such that this is possible. And I'll tell you more about this in a second as well. So the first opportunity is the ability to take what you have and with little cost, move into the cloud. Second opportunity is very much frictionless deployment across the spectrum I mentioned. Same tool, same console, same concept, same model, that depending on other criteria, it could be cost, it could be regulation, what have you, you can target the components in different parts of the spectrum. So this is sort of the second opportunity one can think of. Thirdly, which is something you guys in the room will decide, which is how to then take this to the next step by building new breed of applications that truly can span the spectrum and make use of the best attributes of each part of the spectrum. So the first part is being able to move applications to the cloud, then be able to manage them in the cloud, and then how do you actually invent new scenarios out of the spectrum. I'll come back to the last point toward the end as well. So here's a beginning with a framework to think about this. You are faced with the question, I need to go use this cloud thing. I'm told, take this scenario, make it work in the cloud. Where do you start? We're suggesting you start with these questions. First question, is your application portable? Or are the components of the application portable? That is, do they fit in the cloud model? Or perhaps can they be made cloud ready by changing the code or using some virtualization technology, which I will discuss. So that's one question you have to ask yourself for every component of your application. What are my dependencies for this application set? What other services do I need? Is my application very chatty with those components? Do I need an ID system? Do I need some storage system, and so forth? And where do they live? Thirdly, connectivity. What are the application needs to connect to other components within the application, other components? Do I have to go through firewalls, etc.? Lastly, but by no means least, is what are the business and regulation issues that may dictate how my application will be deployed and run? And I will touch on this thing time and again. And as you will see later on, that question actually affects the basic topology of your service, and therefore affects where you actually would put your data and your computation. So you have to ask it very early on in your thinking. You'll find out that when you analyze the answers to any given project, is that the answers will not be a clear yes or no. If you have a simple application, putting a web page somewhere, maybe the answer is simple. Just I'm going to put it there and I'm done. Your app could be a multi-tiered service that has a mix of some old code that's not really cloud ready, some new code, etc. You may have components that need access to the enterprise network. You have to reach back to your enterprise network to get some data under lock and key. You may have some components very chatty with each other, so you know they have to be co-located. And of course, you're going to have, you probably will have some need to access some, as I mentioned, data or otherwise. It has to be under some regulation, under some rules, business or otherwise. So how do you go about that? The basic process is the following. First and foremost, figure out the topology, the blueprint of your service. And you have to create a blueprint that really takes the location in mind, where the location is not as much the geographical location, but what are the policies of the location, who owns the data, and which regulations and business rules need to be applied first. So yes, there are a lot of technology you have to worry about, but first and foremost, figure out how should the topology look like, and can I co-locate certain places in the cloud, in this cloud versus on-premises, and so forth. So one, get the topology right. Secondly, for each component, you have to go through a cloud readiness study, basically. You have to make each component either cloud ready or use one of the virtualization techniques to make that component cloud ready. And I'll discuss this in a second as well. Thirdly, there are a number of connectivity technologies, I'll touch on them as well, that you can utilize, depending on your solution, to connect the disparate components. You may have to reach back to your enterprise. You may have to federate with some other component by a different supplier and so forth. And we have a host of technologies available now and more coming to make this thing a possibility. Lastly, you need a uniform management infrastructure that enables you to target the different components from the same space, from the same console, from the same PowerShell script if you want to. For today's presentation, I will not discuss much about the management part, but I will concentrate on the other pieces as well. So let's talk about application portability a bit. For newly developed code, you see us really providing tools and environments and methodologies, particularly in .NET and in general managed code technologies, that if you adopt them, you'll be in very good shape to have your code fit the cloud model. And you would retain the ability to actually target them to whatever environment comes along. So this is really the big thing. For new code, as much as possible, fit the cloud model. State-separated code, model-driven deployment is the way to go. And as I mentioned, even if you don't use the cloud this year or next year, it's going to be an investment you want to have going forward. So for new code, make it cloud ready already, even if you're not targeting the cloud today. Of course, all of us have existing code. Call them legacy, call them existing, call them our assets, And this stuff has to be able to move to the cloud one way or the other. And there's a spectrum there. If you have the ability to modify the application to fit the cloud model, do so. In a sense, meet the cloud halfway. Take your current stuff and see if you can change the way it's installed. See how we can change how the config settings are, instead put in a configuration file versus the human having to go and touch them and so forth. If that fails, there are going to also be virtualization technologies to enable the job, both at the machine level and perhaps in the future at the application level as well. Regarding VM technologies, Bob already discussed some of this stuff early in the morning. For example, VM support. This is a way to get you existing code to also move within the cloud model. Don't depend on this thing for everything, guys. This is a heavyweight solution, okay? But if you have some legacy stuff, you have some old code you want to be able just to move through, put them into the forthcoming virtual machine role type. So you can easily configure a system as you see fit. Put all this stuff in there, do MSI installs, go to town, if you will, and at the end, integrate them together in a bigger service model. So this is one of the tools you're going to have at your disposal. There will be others to enable you to take your existing stuff to the cloud and at the same time complement them with code you would write toward the newer model. And together, they will put together in a richer topology that you can go deploy to the cloud. So we discussed sort of briefly how to make your code cloud ready, either by writing new code or using one of those techniques to make it cloud ready. But as you will notice that making those application code portable is only the first step. To be honest, guys, it's sort of the easy step in terms of talking about it, because from there on, you have to figure out how does your application live in the overall topology. And as you know, apps don't live in isolation. They have to get to their data. They have to get to other runtime environments, their dependencies, and so forth. So you need to figure out what all of my dependencies and how do I get to them. Over time, you will see increasing symmetry between services and tools that you have on premises in the cloud. And here's some examples on the slide. And you see it very well today with SQL Server and SQL Azure. In many cases, you change one string for the connectivity string to we want to go to SQL Azure versus SQL Server. You see more asymmetry at the .NET and the Visual Studio capabilities between on-premises and the cloud. And in the future, you're going to see more common models, more end-to-end management that apply the same for on-premises and the cloud. So you end up with a policy decision where you want to go versus worrying about the technology pieces. But in some cases, you may not find the appropriate symmetry. You may not find the service you need on the cloud, for example. And what do? Broadly speaking, you have two options. Either you co-locate the application with the service, in which case you are forced to be wherever the service is, or of course, connect to it somehow. And in practice, you're going to have hybrid or combination of these techniques. But again, when you start with a topology, these things will come quickly at you, and you'll figure out who should be talking to whom. For the connectivity techniques, there are different layers you need to go address the problem with. You could do it at the data synchronization layer, where you might synchronize, for example, your SQL tables between on-premise and the cloud. You could do it at the application connectivity layer using Service Bus, which is great also for federation scenarios. And we can go down to basically the last layer, which is the virtual network overlay. It's really Project Sydney, which is at the network level, you can connect components such that any code, legacy code, new code, et cetera, can connect and work at the network level regardless of the location. I'll explain more about this in the next slide. Basic scenario is that you have an enterprise and you have servers running in an enterprise, be it in traditional IT or more of a private cloud. And you can also have other clouds, public clouds or some other variation of the clouds. The idea is this. You can create a virtual network overlay. This is a virtual overlay, guys. Just think of it as a network up in the ether if you want to, a big VLAN. And you can selectively and securely take any collection of machines from your on-premises or different clouds and put them in this overlay, such that once you are in the overlay, you are as if in one big network. And it's a firewall network only for those machines. Moreover, you can put your development machines in those networks, like this slide shows. So you can do debugging and monitoring directly in the cloud as well. This will be a very powerful tool such that you can take the ability, you can have the ability to take any computation elements, machines from here and there, roles and so forth, and make them talk to each other securely through firewalls and the like. Now guys, laws of physics are not defeated here. So latency is still an issue. So don't just put two chatty components, put them in overlay in the cloud and go to town. You always have to think about really how many messages am I exchanging and the like. But if you have to reach back to your enterprise, like the demo Bob showed this morning, and you know the data in enterprise cannot be moved to the cloud, there's a way to do it here. You can do it, but do note also you have many options. You can do it at the network level, you can synchronize at the data level. These will be tools in your arsenal to help you architect your rich applications that can span these different boundaries. I will take Q&A at the end so we can go through more details if you want to. Last but by no means least is the business and regulation angle to all of this. Any of you who've been faced with the question of, let's go do a deployment of rich applications, we're faced with those kind of questions. There are, of course, regulations, compliance questions, certifications, some from the government, some from industry consortium and the like, SOX, HIPAA, PCI, and others. There are, of course, also national boundary laws. Many countries have laws that says data, which is privately identifiable, cannot cross national boundaries. So it has to live in a certain place, in a certain data center, for example. There are also, of course, business requirements. Some businesses have strict rules about policies, what data can live where, within their boundaries or not, and so forth, IT policies and the like. Key point here is that you must consider these things very early on for one key reason, because they affect your topology, affect who can talk to whom and where they should be living. They affect the basic topology of the service, they affect the location of the data, and of course they affect the communication patterns, because once you put them in different places, do I have to cache, do I have to synchronize, etc. The other key point I want to impress on you is this, which is the last point in the slide. Off-premises clouds will over time gain more certification, more ability to run things like PCI and HIPAA and SOX. But do not assume that, even in the long run, that everything will move to the cloud, because there will always be a need to have computation on premises. There will always be things that the business, for no other reason than to control the data, I must have it in my private cloud or my private data center. So in our opinion, the spectrum I started with will always be with us. Perhaps we will emphasize more parts of the spectrum than the others, but it will be there. If for not to take technical reasons, for the reasons on this slide, for the business reasons, for regulation reasons. So expect these questions we are raising here to be with us for a while. Where should I run my stuff? So let's put it all together. So in terms of a summary of the steps. First, examine your app components and the communication paths. For many of us in this room, I know we do this thing, but think of it in terms of the cloud as well. Ask the questions listed before, and decide an overall topology, which will inform many things for the following steps. So get your topology right. Then look at each component and make them cloud ready. And as I mentioned, there's a spectrum of options there, from writing new code that fits the cloud model, to modifying existing code, to using some virtualization technology to run existing code. At the end of the exercise, your code will be ready to run in the cloud. We're ready to be automated through service models and to be managed basically from one single console throughout the spectrum. So get the topology right, get the code then cloud ready. And then you have to connect them based on the topology you chose. As I mentioned, there's a spectrum as well of connectivity options, from data synchronization to application level connectivity, all the way down to network connectivity. And in some cases, you want to use one solution versus the other. And frankly, guys, this is what they pay us for. So I know one has to think about these things, but it's important to get these things right. Of course, as I mentioned about laws of physics, be very careful of latency and communication boundaries. Although you may have a technology at your disposal of actually going through a firewall or connecting through this component and the other, you still have to go through the network. And there's still distance issues here. So make sure those components are not chatty. And that will dictate perhaps a code rewrite in some cases, or adding caching layers, of course. And do synchronization and caching to basically do latency avoidance or latency mitigations. And always remember, security, business, and regulation requirements will affect anything you do in this space. And at the minimum, it will affect the topology as well. I want to say a bit more about the last point here. Even if we convince ourselves as technologists that this solution will work, that it will be secure, that I can put it behind this firewall and so forth, in our industry, the notion of trusting the cloud and trusting certain providers and others will be there. It's still with us for a while. So early on, figure out if your business partner, your approver, will be willing to approve a certain topology, a certain place to put your data. Because it may, at the end, boil down to not a technology discussion at all, but more of a trust discussion. More of, I don't want it to be there yet. Okay? Beyond bridging the gap, there are things we can envision going forward from there. So the principles discussed so far have been around enabling moving the app to the cloud. While bridging back to the enterprise and enabling you to have the ability to go where you want to go. And of course, as I mentioned, we have current technologies and future ones that will enable more frictionless deployment and management over the overall spectrum. But what's next? Okay, there's transforming scenarios one can think of once you sort of tackle the areas I mentioned. And I just put a partial list in there. You can really think of business continuity programs and solutions here, where disaster recovery and failures can be handled because you have mastered the ability to put components in different places. And you have mastered the latency issues and the data synchronization issues. These, by the way, are a prerequisite for you having truly disaster-resilient application sets. You can envision many collaboration scenarios, extranet applications, and federation scenarios as well. That are all enabled by you being able to live in multiple places across the spectrum I mentioned earlier on. And of course, if you want to really fast forward here, you can really think of the global cloud. And I have to admit, I'm moving a bit more in the future here. But once we master all these abilities and we have the ability to deploy to multiple locations, be they, again, public clouds, some other variations, or on-premises, you effectively have a global cloud computing infrastructure here. Across the globe, 24/7, on demand. And one can only imagine what kind of application sets can utilize such a big, huge computer. You've heard probably terms like cloud bursting and global load balancing and nice terms like that. They're cute, but ultimately, they depend on the basic principles I discussed right now, which is how do I move from here to there, and how I do it with being latency tolerant and so forth. And you can also envision things like global application networks and data delivery networks that can work across the whole globe. So guys, I've been speaking quickly. I'm basically done with my set presentation. And I would like to use some of the time remaining to have a discussion with you on some of this stuff. I avoid to put more slides, and I would like to have, if I can, a more collaborative discussion with you guys. So, questions? If you can use the microphone, please, I will repeat the question.
Hi. I always have this question that in the finance world, right, the data has to remain on-premise, right? So in case of a few type of applications like a data warehouse, OLAP, time series analysis, and the transactions, is it fair to say that those kind of applications are not suited for going cloud?
The question is about basically what kind of data can move to the cloud. And you mentioned transactional data and warehousing and the like. To be honest, the two parts of the question along the same themes I mentioned. One is technical, and one is really non-technical, more business and regulation question. So assuming that the second one is answered as yes, I can move it out there because there are no privacy issues and the like, it becomes a question of how much data it is and how much am I going back and forth across these boundaries, right? assuming you can move to the cloud, you can really imagine solutions where you are synchronizing data between on-premises and the cloud and doing heavy-duty computations in the cloud. For example, by utilizing a large number of machines. You really have to examine the traffic, how much data you are transferring, and how much you want to compute. There are applications out there, by the way, that the data transfer is small, but the computation need is very, very high and very on demand. And these are just perfect for the cloud. Others, if they are very static, or as I mentioned, under other constraints not to be moved, you want to keep them on premises. Unfortunately, there's no one answer, one simple answer to tell you it has to be done this way versus that way. Thus, the need to be armed with all these options, as the case may be. Question?
Yeah, you mentioned in application portability about existing apps that there was some future directions for application virtualization technologies. Can you expand on that?
As I mentioned, I mean, this is more a future-looking thing, but you can envision being able to take an application level and virtualize that as well. So what does that really mean? I mean, why are apps sometimes hard to run in the cloud? They're hard to run in the cloud because they have state. They have configuration settings and the like that they leave around, and they're not very portable, if you will. So you can envision having boundaries and containers that actually virtualize that level as well. I'm not going to announce anything at the moment, but if you think about it, there's a spectrum possible there between the VM boundary and change the application that may be possible in the future as well. And as you know, it's probably done on the client side as well in virtualizing client-side applications. So potentially it can be done for server-side applications too as well. Question?
Considering the VM role, what do you think about using the cloud to host environments such as test and stage environments in the cloud instead of hosting that on-premise?
Yeah, the question, yeah. To be honest, that's a common scenario today. The question again is about how hosting test and development scenarios in the cloud. It's a very common scenario today, to be honest, because you have the ability to avoid building all these extra machines locally and so forth, and you have the flexibility of a testing environment in the cloud. This notion of having to build your own test clusters as separate from the production clusters can go away with clouds. And even in today's products in Windows Azure, today's feature set, you have service management APIs that you can go script yourself locally and incorporate as part of your test and build cycle. And we're seeing people doing this thing as well. When you have things like VM roles and the like, it will even expand the possibilities of taking also testing environments and moving to the cloud as well. You can envision even products by third parties building over the same infrastructure as well. So that scenario, I believe, is relatively easy to envision, and actually we're seeing it already happening in pockets.
But actually we see that using the Azure services, but I'm talking about using the VM role, so you can basically install your software and make the test environment the way that you want. Yeah, it's possible also?
It will be possible in the future, yes. Because the idea of the VM role is you can install anything through normal scripting tools. So whatever you do it on premises, you can do it in the cloud too.
Okay, thank you.
What happens to, this is more of a data question, what happens to the whole sizing exercise? So if you have a performance-intensive load, and we typically do a hardware sizing to make sure that we can get the right size of the database server. So if I'm moving onto the cloud, what happens to this whole sizing paradigm and the topology decision?
Very good question, to be honest. It's a question about the sizing exercise. Typically, nowadays, when you develop a service and application, part of the steps you do before you actually deploy it is you size it. You figure out how the machines look like, maybe order more memory, more CPUs, and so forth. Guys, the thing with the cloud is, all the features, all the benefits we discussed in the cloud, lower OpEx and CapEx and higher agility and the like. One of the key reasons is that a given cloud system is really fixed. It's a scale-out system, not a scale-up system. That is, the hardware SKUs are more or less the same, hardware sizes, if you will. You have some flexibility how much VM and VM size you want to have, how much memory, but by and large, it's a predefined environment that if you need more computation, you get more of the units it can give you. It can give you bigger VM sizes, more VMs, it can give you more memory within a limit, but that's it really. So some of the traditional things we do in traditional IT are not applicable to the cloud. And that has two implications. One is your app better be able to be scaled up, or you may have to stay on premises. Another reason why I believe on premises will not go away anytime soon. Because you may actually truly have a transactional, for example, application that requires 64 CPUs with a half a terabyte of physical memory. No cloud provider will give you that, but your central IT department will give you that. And in our model, that should just fit. You connect to it and you go. Yeah. Yeah.
So if I may,
Yes.
just slightly push the security and compliance thing a bit further out into the future. What you've said about making your choices looking at not just the technical, but also your compliance and everybody else, all the other stakeholders, that makes a lot of sense right now. What I'm wondering is if going into the future, does Microsoft have a policy of looking at working with regulators, getting more trust explicitly put into the cloud, or are you more banking on this hybrid model?
To be honest, this is truly a great question. Let me just say it in my words, if you will. So I discussed very much the fact that almost a given that we'll have to live with a hybrid model because of all regulation issues. And what do we do policy-wise to influence the regulation models, if you will? Yeah. Let me elaborate a bit. If you look at some of those regulation and certifications, okay, for example, take PCI. If you read the actual certification book manual, it tells you should do the following. Put this machine here, put the machine there, I'm simplifying. Put a firewall here, and so forth. So a very physical description of how things should be done. Yet we're talking about the cloud here, where things are so malleable and everything's done through software. So yes to your question, I think that Microsoft will do, the thing that the industry should do as a whole is to work with regulation bodies and with governments to take technically equivalent solutions to those currently written regulation manuals and the like, and apply them to a more virtual environment. That's a process actually starting in many ways. And I expect some of it will bear fruit. But you also understand that implies going through also bodies out there. Sure. Government bodies, different jurisdictions, different organizations and the like. Technology-wise, you basically want to, again, map the physical aspects of these rules into virtual rules. And we will do that. We will work with others on that. The industry at large, though, is a bit immature in this space yet. I do expect more of it to happen. But will it all happen tomorrow? Not really. Sure. And will it cover the whole spectrum? Maybe, but I'm not sure. That's why I still believe we're going to have this spectrum. But we are hoping to get more and more regulation that fit the virtual model versus the physical model.
Okay. Thanks.
Thanks.
Excellent talk, by the way. Here's a scenario-based question. You have a client that comes to you. They want a zero data center footprint. They want an entirely self-contained cloud-based application, but they also want it to be stateful. Your guidance.
To be what? I'm sorry, last one?
To be stateful.
Stateful.
To maintain state.
Yes. And in your case, is the state subject to any rules, as in regulations, compliance, and the like? Because having stateful data in the cloud is just fine. There's no issue with that. You put SQL Azure, you put Windows storage, whatever the case, Windows Azure storage, whatever the case may be. The question you need to ask yourself is, other than the technology aspects, can I put the data there? Okay. Will my hoster, be the public cloud or otherwise, able to give you or your customer the guarantees they expect? Okay. In many cases, they can. Okay. If it's an ISO 27001, that should be relatively straightforward. If it's the government of a certain country saying this data shall not be anywhere but in my national boundaries, that's hard. So don't get me wrong, stateful data is fine being in the cloud. Actually, we very much want it to be out there. But some cases, it has to be not there for purely non-technical reasons. And in this case, no technology will help you really.
So what I hear you saying is, if I want to maintain business state, just use SQL Azure to persist that. What if it's an orchestrated workflow?
Again, the workflow engine can be running somewhere, and it can orchestrate data among different locations, which may or may not be in the cloud, data-wise. We should talk offline, but okay. Those options are all on the table, and they're being exercised by others as we speak.
Okay, thank you.
You're welcome. Go ahead.
So you mentioned checking your code for being cloud ready. So I'm imagining, is Microsoft thinking about any kind of helpers in that regard? You know, I'm imagining not in software, but you know, FX comp for .NET was checking. I'm not saying you can do that with legacy code, but
sure.
but the same kind of idea of things that you can check for that you may not even be aware of in years of legacy code and things like
I'm
that.
with
There's
you.
so many aspects of it.
To be honest, part of the demo this morning, we had to cut out because of the time constraints was a checking step. So the same tools that they were demoing, some of the current ones and the future ones. Since it's service model driven, we have that ability. Okay. The key point is that we have a model that describes the connectivity and the basic assumption of communication between them. We will be writing more verification tools based on that model. So one of the advantages of being model driven is that we can provide such tools. And guys, the magic there is that all the model says that you, the developer, the architect, are telling the tool chain, this is what I expect. So tool chain can do some intelligent checking for you. And a basic check, for example, is make sure you have enough number of roles for availability. If you have one instead of two, for example, I can tell you that. But there are other kind of checking we can be doing. And again, the more we collectively move to model-based systems, the more we can do such checking. With the cloud in mind, of course.
I have a question.
Oh, go ahead.
Go ahead.
Speaking specifically about data portability, in the symmetry between SQL Server and SQL Azure, do you see any major challenges in trying to move a large relational database into the cloud? And what options would be available there? What type of symmetry may conflict between the two?
So the question is about moving large amount of data into the cloud. There are two parts to answer the question. One is there is the, if you will, the initial steps of populating the data in and perhaps backing it out, or perhaps synchronizing it, which becomes more of a latency throughput thing. Can I get it done or not? And there's a question of how much a given technology at a given point in time can support in terms of table sizes. So answering the second one, we have some maximum size for database sizes today in SQL Azure, but those numbers will go up. I don't see an issue there going forward. For the first one, as I mentioned, there are physics involved. So you need to, but this is very similar to moving populating any data one way or the other.
And that's sort of why the Sydney model might actually work in this scenario because of latency issues, but you do think the limit will eventually increase in terms of database size?
Well, to be honest, it all depends on sizes. I mean, if you want to move petabytes in no time, the fastest way is FedEx still. Seriously.
Right. Okay.
So, again, it depends on what sizes we're talking about here.
Yeah, nothing too over the top, just a typical large enterprise-y application database.
Give me a number.
A maximum of, say, 15 to 20 gigabytes.
That's easy. That's not an issue even today.
Okay. All right. Thank you.
Yeah. See the T? Terabyte. Terabyte, no, that you want a FedEx for now. Seriously. If it's a B, it's easy. Yeah. But
So actually, my question was going to be tagged on to sort of like that. If you have non-transactional, large volumes of non-transactional, periodically updated data that needs to be close to your application code for performance.
yes.
FedEx, is that the way?
Again, it depends. If it's once you get the basic set there, if we're talking about an update rate, we can do the math on a piece of paper. And if the update rate is reasonable enough, you can go through the network, not an issue. If you need to update like a terabyte or two a day or something, it becomes costly. Which you want to think of more of a physical notion, like a disk drive being shipped. Again, there's all physics here. I mean, networking technology is fast, but there are limits to that.
So do you see that being supported in the public cloud?
I believe so, personally. Again, we're not announcing any roadmap stuff here, but the whole notion of being able to get bulk data in and out is important. Mm-hmm. You want to get them in for the scenarios you mentioned. You want to get them out for disaster recovery and backup. That's natural. And whatever customers want, we should be able to provide. Okay, one more question. Go ahead.
You were talking about utilization rates of around 15% on traditional data centers and
Take it with a grain of salt, but
50%
yes. Yeah.
with virtualization. How would a cloud server achieve higher rates of utilization than 50%? Would that be through sharing resources among customers of that server?
Just adding virtualization will get you around that 50% or so by basically sharing the same physical boxes, if you will. What cloud computing gives you in addition to that is the ability to scale up and down quickly because the application is basically modified to fit the scale-up model. So the time it takes to add computation and remove computation can be quite fast.
So it's
So
an
you can do-
advantage to the client of that
I'm sorry?
center. It's an advantage to the user of that cloud service. They're only paying for what they use. But for the person implementing and hosting the cloud,
Yes.
how do they achieve utilization rates above 50%? And one way I can think of is by sharing resources among their customers.
Definitely, public clouds typically put the same different customers, multi-tenancy model in the same physical machines. So the way it makes sense for the hoster, if you will, by having effectively scale. Scale is a big deal in public clouds for cost reasons and other reasons. By having enough customers, enough machines, you can truly compact these things and end up being able to move things as demand moves or changes very quickly. This discussion ties to capacity planning. We should discuss offline because there are interesting implications there as well. So your provider should have enough scale, so enough weight for them to be able to give you these advantages and for them to actually make money with it as well.
Okay,
Let's
thank you.
get me offline, please. Yes.
Seems pretty typical that an application being hosted with Azure hosting and then the data set being in SQL Azure, that's going to be a pretty typical scenario.
Yes.
What type of connectivity is available now between those two environments, and what are the SLAs going to look like both now and also down the road?
The information about now are all available, which I can provide you offline. But today, basically, it's intra-data center connectivity. The cost for it is zero within the same data center, basically. The SLA is documented. I can give it to you offline.
Okay.
So today, we have the information ready and going, if you will. Questions about perhaps other kind of scenarios, we can go speculate if you want to. But today, we have the information you want. I'll give it to you offline.
Okay, thanks.
Sure. Okay, go ahead.
Hi. So presently, our organization is doing work with Dynamics as a platform, SharePoint as a platform, and also custom web apps. So the natural progression for all three of those is, SharePoint Online, Dynamics Online, and Azure. But I've been using all three of those basically throughout the CDP of Azure, and they seem to be three separate entities almost. Is there any plan for those to be the same, or it seems that SharePoint and Dynamics are sort of a little bit behind the curve as with relates to like where Azure is?
I understand. Our strategy is very clear on this, which we articulated last PDC in here actually, which is the plan for all these services over time to move over the Windows Azure platform. And actually some of the stuff you see here are running already on Windows Azure. It is true that there are different schedules and maturity levels for the technologies, if you will. But we are basically committed to moving everything, have symmetry for many of those services between the on-premises versions and the cloud. Okay, so what you're seeing is basically is correct, but it's a transient in time, if you will. And we can again discuss some of the internal schedules we have for these things. But we are moving everything, all these basic services, they're moving to the cloud as well as having on-premises version of them. So you can have both options. Okay, great, guys. So we're almost out of time. Thank you very much. I'll be available offline if you need me. And I can catch you guys for the other questions you asked me. Thank you.